Picture this. You're late to a meeting, racing through the city streets, guided by the voice of your GPS. It might seem like magic, but there's a science behind it. A science that's deeply interwoven with the fabric of the cosmos. It's astrophysics. Astrophysics, you ask? Yes, indeed. The GPS technology that we heavily rely on for navigation utilizes principles of astrophysics to function. The satellites orbiting Earth, which make GPS possible, follow the laws of motion outlined by Sir Isaac Newton, and the principles of relativity proposed by Albert Einstein. These satellites are constantly moving at high speeds and far from Earth's gravitational pull. Here's where Einstein's theory of relativity comes into play. It explains that time moves slower for objects in strong gravitational fields. Hence, the clocks on these satellites slightly outpace those on Earth, and adjustments are made to keep the GPS accurate. So, the next time you're navigating through city streets, remember it's astrophysics that's guiding your way. Now, think about the last time you made a long-distance call or sent a text to someone on the other side of the world. It feels like magic, right? But it's not magic, it's astrophysics. Our phone calls, text messages, and even our favorite TV shows are all beamed around the globe through an intricate web of satellites orbiting high above us. These satellites are the unsung heroes of our modern connected world. But have you ever stopped to wonder how they work? Well, it's all thanks to astrophysics. The principles of the science govern the behavior of these satellites. They orbit Earth in precise paths influenced by the laws of gravity and motion. It is astrophysics that determines their speed, distance, and the paths they need to follow to stay in orbit and not collide with each other. Let's take a real-world example. Do you remember the last Summer Olympics? It was watched by billions of people across the globe. You could be sitting in your living room in New York and cheering on your team in Tokyo. This instant global connection was made possible by a network of satellites, all governed by the principles of astrophysics. So the next time you make a call or send a message to someone far away, take a moment to appreciate the invisible web above us. In essence, astrophysics helps us stay connected in this ever-shrinking world. Have you ever wondered about the northern lights or the sudden disruption of satellite communications? These marvels and mysteries are all linked to an intriguing field called space weather. Like our terrestrial weather with its winds and storms, space too has its own weather, primarily influenced by our sun. The sun constantly emits a stream of charged particles known as the solar wind. At times, it can release a massive burst of this solar wind, a phenomenon known as a solar storm. But why does this matter to us on Earth? Well, our planet is protected by a magnetic bubble, the magnetosphere, which usually deflects these particles. However, during intense solar storms, some particles make their way through, leading to those stunning displays of northern lights or auroras. Yet, this interplay of solar particles and Earth's magnetic field isn't just about creating a celestial light show. It has profound implications for our technology too. Solar storms can disrupt satellite communications, interfere with GPS systems, and even cause power outages. By studying space weather, astrophysicists can predict these solar storms and help us prepare for such disruptions. Understanding the physics of our sun has direct implications on our daily lives, from ensuring the reliability of our GPS navigation to maintaining the functionality of our power grids. So while we might not always see it, astrophysics plays a vital role in maintaining the technology we depend on daily. From getting you to your destination to keeping you connected with loved ones to protecting our technology, astrophysics is more than just a science about distant stars and galaxies. It's a hidden force that shapes our daily experiences. We've journeyed through the unseen web above us, where satellites orbit, navigating us through city streets and sprawling landscapes. We've delved into the realm of space weather, its invisible power impacting our technology, from the humble smartphone to the most complex power grids. And while these cosmic principles might seem distant and abstract, they're actually closer than you think. They're in the GPS that guides your car, in the satellite communication that brings your favorite show to your screen, and in the space weather forecasts that protect our technology. Astrophysics, it turns out, isn't just about exploring the universe. It's about making sense of our daily lives here on Earth.